Here we have our system, two variables, two equations, and we're going to solve for x and y. Now, we're going to solve this by using this strategy. We're going to eliminate one of the variables and then solve for the remaining variable. And we're going to do this to start with by subtraction or addition. So in this case here, I have 3x plus 8y equals 21. I have 2x minus 8y equals negative 6. Well, what this means then is I'm just going to number these equations. There's equation 1. I'm going to number this equation 2. Just keep track of them. And I can see that if I add these two equations together, the 8y's will cancel out. They will undo each other. Essentially, they will be a zero pair, and all we're going to be left with is x's. And if we're left with x's, we can solve the equation. So I'm going to take equation 2, and I'm going to add equation 2. So I have 2x minus 8y equals negative 6. When I combine these two equations, which I'm allowed to do because it's going to keep it balanced, I'm going to end up with 5x's here. These cancel out. There's zero pairs. 21 minus 6x, or 21 plus negative 6, is going to be positive 15. I now only have one variable to solve for, so I'm going to divide both sides by 5, and I get the answer x equals 3. Okay, we'll have to remember that the solution to a system is an x and a y coordinate. Because remember, if we're graphing this, we have an x and a y coordinate. So how do I go about solving for this, the y value? Well, if I have one variable, I can plug that x into either equation, and that will leave me with just a y left to solve for. So I'm going to plug it into equation 1. Now, I could have put it into equation 2, but I'm just arbitrarily putting it into equation 1. So instead of 3x, I'm going to do 3 times 3 plus 8y equals 21. And when I do this, I can see that there's only one variable left in this equation, because before I eliminated y, but now to solve for x. But now that I have x, I can plug in and then I can solve for y. So I end up with 9 plus 8y equals 21. Subtract 9 from both sides. I get 8y equals 12. Y equals 12 over 8, which I'm going to reduce to 3 over 2, or 1.5. So there's my solution for y. Now I need to check this because I want to make sure that this actually fits both equations, and in fact is the intersection of both relationships. So I'm going to test it over here. So I'm going to check it. My check is going to be 3 times 3 plus 8 times 3 over 2 equals 21. Okay, so that's my equation 1. And that's 9 plus 12 equals 21. Check. I'm going to test my equation 2. So 2 times 3. I'll put the 3 here just so it's clear. So 2 times x minus 8 times y equals negative 6. So I end up with 6 here. Minus 12 equals negative 6. That's equation 2. Yeah, it works for both equations. It must be the intersection of these two relationships. So my answer for x and y can be written as a pair. X equals 3, y equals 3 over 2, or as an intersection point, 3 and 3 over 2.